Hi class, I wanted to give a quick demonstration about how do we use Jamovi to run an independent samples t-test. So first I'm going to look for some data. So I'm going to use our stats survey that we had earlier in the semester. And what I'm going to do is I am going to look at an independent samples t-test. So the things that I need are, first off, a variable that has two groups. So a variable such as gender has just two groups in this data set. So I have females and males. And I want to look at a continuous outcome. So there might be something like, do females and males differ on how far they live away from campus? That was my distance one. The only other continuous one I have is age. So we could do something like, do females and males differ on the average age in this class? So I'm going to go with gender. Does gender influence how far away you live from school? So I don't have a directional hypothesis, just so that you know, but I can do a couple of things. I'm just going to show you the quick and dirty way of doing the t-test. So when I'm in analyses, I'm up here with t-test. I'm just going to click on independent samples t-test. And what I have are two things that I need. I need my dependent variable. So that is my outcome, the thing that I really care about. So in this case, I care about how far away people live from campus. So I'm going to click that over. One of the things that you'll notice here also when you talk about the independent samples t-test is that you have the little ruler that shows that this is a continuous variable, and it matches what you need in the dependent variables box. So if you're forgetting exactly what a dependent variable is, it's the one that's continuous. The second thing I'm going to do is I'm going to put in my grouping variable. So I care about gender. So are females and males different on how far they live away from campus? And just click that on over. Again, I have the three little things, which means that it's a nominal variable. And this, I guess, rising bars means that it's a ordinal variable. So if you remember, nominal is just I'm naming males and females. There's no difference in whether or not, right, like you can't rank them. So I am going to do a students test. That's all we're learning in this class. I did not have a directional hypothesis. So here, group one, I think is defined. Actually, that's a good question. What is my grouping variable? So here, when I look at my results, it doesn't really say, but one of the things I can do is click descriptives, and it should give me some information. So it looks like my group one is female, and I'm doing that based on alphabetical order, as well as the fact that it shows up first in my descriptives. And you can also see this with the mean, right? So my test statistic is negative, which means that it's females are less than males. So that does mean that my group one is female. Missing values, I didn't have any missing values, but analysis by analysis is perfect. You can have other statistics, right? So I could put in a mean difference. So here I can now see what is my difference between males and females. You can also have a descriptives plot. So sometimes it's helpful to kind of like look at what your data looks like. And one of the things that we had as an assumption is that these two groups have the same variance. So homogeneity test is saying, do these two groups have the same variance? Let me go over the results. So this is just what can I do? Here are the results. So my independent samples t-test, it tells me that I'm comparing two groups on distance. It isn't actually telling me what groups there are, which is kind of a bummer because you want to know, like, what are my two groups, right? But it's telling me that I did a student's T. It gives me the t-score. So this is the t-score, is the statistic. So negative 1.28, we know that kind of putting them on the same level, our statistic is a negative number. It gives me how many degrees of freedom there are total. So this is including both males and females. So in this case, we can look down, we have 16 people total, and basically if we add up the degrees of freedom for females, which is 9 plus 4 or 5 for males, then we get a degrees of freedom that it equals 14. And the thing that's important here is my p-value. So we want less than a 5% chance that we get this result just by chance. So if our p-value is less than 0.05, we say it's significant, and in this case, this is not significant. So when I'm looking at that null hypothesis, the null hypothesis was that males and females are going to be the same. In this case, I cannot reject the null. So I have to say, based on our data, our results are kind of inconclusive, but that males and females seem to have live the same distance away from campus. So even though there's a difference here, right? So the difference between males and females is 39 miles. So females live closer compared to males. So some of the assumptions that we make is that our two groups have the same variance. And in this case, this homogeneity of variance test, since we have a high p-value, which is actually good, right? It's kind of like we are not rejecting the null, but that's good, right? Null means that there's no difference. So here, it actually gives me a little thing, a low p-value, which is not what we have. Suggests a violation of the assumption equal variances. Here, our assumption is met. So we can say that these two variances, so how much they range, are the same. And we can actually see that here. So in our distance plot, we have our average as listed here with the little circles. And then we have our squares, which is our median. So as you can see, like on average, females seem to live about, 70 something miles, and males seem to do about, almost 120 miles away. So one of the things that's nice though is they have these things called error bars. So those are the two bars above and below that shows you the variance. So this shows you, here they say it's a 95% confidence interval. So basically our range of scores, 95% of them for females range somewhere between 40 and 120 basically. And males, it's like somewhere around 60 to 160. So that's where most of our scores are going to fall. But the nice thing about this is that you can kind of compare, like, okay, so this is a range of scores. Let's say it's about 80 miles. Here, this range of scores, 70 to 160, is about 80 miles too. So these error bars look about the same. So that's how we know that the variances are about the same for both females and males. So if I'm looking at kind of like the number or the error bars. You can also look at that with their standard deviation, right? So standard deviation, if you square both of those, you can kind of compare. Oh, they look about the same. So the other thing that's nice is that you can get your group descriptives, so you can look at what the mean, the median is, and your standard deviation. So hopefully all of those numbers kind of make sense. So there you go. You just ran an independent samples t-test.